Hello and welcome to the video notes for Chapter 9, Lesson 5, The Effects of Changing Dimensions Proportionally. The objectives of this lesson are to describe the effect on perimeter and area when one or more dimensions of a figure are changed, and apply the relationship between perimeter and area in problem solving. So we're going to do a quick little warm-up to refresh our memories with these. We need to find the area of each of these given figures and express answers exactly using pi if we need to. So take a few minutes to do the warm-up and then we'll check our answers together. Alright, here's what we should get for the answers of your warm-up questions. For number 1, a square where the side is 4 meters gives us 4 times 4, or 4 squared, 16 square meters. Number 2, a circle in which the radius is 2 feet. Pi r squared gives us 4 pi square feet. And number 3, when we graph the triangle as A, B, and C, we get a base of 8 and a height of 3, so 1/2 base times height is 12 square units. Alright, let's take a look at what the effects are of changing one dimension of a figure. All these figures are going to have two dimensions. We have a length and a width type of measurement. These are two-dimensional figures. They exist in a plane. So if we only change one of those dimensions, it's only going to have a certain change on your area of the given figure. Now, I'm going to show you how to do this without using the actual measurements first. So remember that we've got a triangle. The area of our triangle is 1/2 base times height. They ask what will happen when we multiply the height only by 6. So we go from having just 1/2 base times height to our new area being, again, 1/2 base times height, but the new height is 6 times the old height. Well, we're only multiplying by 6 once, so our area is just 6 times as much. Or you could say the area is multiplied by 6. Because we're only changing one dimension. I'm only multiplying by 6 once. I'm not multiplying both base and height by 6. Okay? And to test this, go back and use your dimensions. The original area is 1/2 base of 12 times height of 5. Our new area is 1/2 base of 12, but the height is 5 times 6. We multiply the height by 6. This simplifies. 1/2 base times height here simplifies to 30. This simplifies to 180. If I take 30 and multiply by 6, I get 180. So once again, this is the answer we're looking for. Either way of writing that. Let's try and do this problem again when we're dealing with something in the coordinate plane. Now you'll notice I didn't give you a graph. That's okay. We don't have to work this out. We're referring to a shape of a kite where I've got these vertices and I'm multiplying the diagonal SU by 1/3. Multiplying by 1/3 is actually going to make that smaller. But if you look at your area formula for a kite, remember, area of a kite is diagonal 1 times diagonal 2 divided by 2. If I take this diagonal, just one of them, and multiply by 1/3, look at how many times we multiply by 1/3 in our formula. We're only multiplying by 1/3 in this one factor. D2 does not get multiplied by 1/3. The 2 does not get multiplied by 1/3. So our area is just multiplied by 1/3. We don't have to graph it. We don't have to do any calculations. When we change one dimension only by a factor, the area changes by that same factor. So let's take a look at example 2. Now let's take a look of changing dimensions proportionally. So we're not just going to be changing one dimension here. We're going to be changing more than one dimension. So let's take a look. 2a, we are to describe the effect of each change on the perimeter, or circumference if it's a circle, and the area. So we have two things that are changing. So we're multiplying the base and height of a rectangle by 2. Both doubled means times 2. So we've got our rectangle that's 4 feet by 5 feet. Go ahead and draw a picture. Four feet by 5 feet. If I am to double that figure, then I no longer just have 5 feet for this base, or this height. Sorry, I've drawn this a little bit backwards. They say the base is 4, the height is 5. No longer have base of 4 and height of 5. I'm going to double that. So it's not just 5, it's 10. And I'm going to double the base. But that changes these dimensions as well. So now it's a 10 by 8. Well, notice that our perimeter is twice as long now. Instead of 5 plus 4 plus 5 plus 4, I have 10 plus 8 plus 10 plus 8. The perimeter is multiplied by 2. It's doubled. But the area, our area was 20. 4 times 5 is 20. Now it's 20 here, 20 here, 20 here, and 20 here. So our area is not multiplied by 2. We go from an area of 20 to an area of 80. 20 times blank equals 80 means we are multiplying by 4. Area is multiplied by 4. Quadrupled. Let's try that again. We have a circle here. The radius of circle J is multiplied by 1/5. Now, if they say the radius is changing, you might think, well, that's only one dimension. But remember, a radius applies this way, and this is also the radius. So these represent both dimensions of the circle. These are both a radius. So I'm going to multiply by 1/5. Well, that means my circle is shrinking down by 1/5. It's getting smaller. Okay. So let's take a look at circumference formula and area formula this time. Circumference is pi times diameter, or you could say circumference is 2 pi r. Area is pi r squared. So let's apply these changes to the formulas. I'm going to take 1/5 of that radius. Okay, I'm going to apply my change to the radius of each of these formulas. 1/5 r, 1/5 r. So my new area is pi times 1/5 of the original radius squared. My new circumference is 2 times pi times 1/5 of that radius. Let's simplify these to look at the factor by which we're changing these other things. 1/5 r all squared means I should square the 1/5 and r. 1/5 squared is 1 times 1 over 5 times 5, and then r squared. So pi r squared is multiplied by 1 over 25. And in our circumference, I'm going to take my 1/5 times the 2, or just bring it out front. Sorry, 1/5, not 1/2. Then I still have pi 2 pi r. Let me simplify that for you. Since we're only multiplying by 1/5 once, I'm going to bring it out to the front, and I still have that times 2 pi r. So the part that we are changing in each one of these are these parts. So the area is multiplied by 1/25. The circumference is multiplied by 1/5. Circumference is multiplied by 1/5. area is multiplied by 1 over 25. But look at 1 over 25. That was saying 1/5 squared. So what this shows us is this rule. However we change the dimensions of our figure, as long as all dimensions are changed proportionally, we'll get similar figures as a result because of this. When we change dimensions, if all dimensions are multiplied by some factor a, the perimeter or circumference are just changing by that same factor of a. But the area changes by the factor of a squared. And this you might recall from when we talked about similar triangles. So let's take a look at another example. A circle has a given circumference. If the area is multiplied by 4, what happens to the radius? Well, remember, if the dimensions are multiplied by a, the circumference is also multiplied by a, then the area is multiplied by a squared. That's the rule we just looked at. Well, they tell you what has changed in the area. They say the area is multiplied by 4. That's the a squared. So in this case, a squared equals 4. I want to go to what a equals, because that's how we change circumference. We multiply circumference by a. So if a squared is 4, that means a is just 2, the square root of 4. So my circumference is going to be multiplied by 2. But also, the dimensions are all changed by that same factor. Well, the radius is the dimension of a circle. So radius is also multiplied by just 2. The square root of 4 is how we got that. Okay, in 3b, we have an equilateral triangle with a given perimeter of 21 meters. You'll find in doing these problems that information isn't always important. But we know this. We know that the area is multiplied by 1/2. What's going to happen to the side lengths? Well, once again, we're going to write this out. Okay, the dimensions are multiplied by some factor a. Then the perimeter is also multiplied by a. But the area is multiplied by a squared. Well, they tell you the area is multiplied by 1/2. That means the a squared equals 1/2. So I want to get to what a is. Well, to do this problem, we have to square root both sides. So a is the square root of 1/2, or root 1 over root 2, which is 1 over root 2. But remember, we should probably rationalize that as multiplied by root 2 on top and bottom. So a, in this case, works out to be root 2 over 2. Again, that is the same as the square root of 1/2. That's how we got that. So the factor of change for both perimeter and the dimensions, the side lengths that they're asking about, is root 2 over 2. So we can say sides are multiplied by root 2 over 2. Remember, we got that by taking the square root of 1/2. All right, that finishes up the most of our examples here. We'll look at example 5 a little bit later on. We may get time for that in class, we may not. But this gives you an idea of what we will be doing in the assignment over the effects of changing dimensions for perimeter and area.